Good morning, everybody. We're going to start the class. So the topic for today is errors in mathematical approximations. Before we start the class, just some um, some observations. So I'm going to be delivering the lecture now. Then if you have any question, all of you are all muted now. So if you have any questions, why I'm talking, why I'm delivering the lecture, then you just type it in the chat. Then from time to time, I will look at the chat and I would respond to the questions. So the class is on errors in mathematical approximations. So before we actually start today's class, I want to go over the assignment. So assignment 3, so a student asked me how to do that same assignment using Excel VBA. I've actually uploaded the solution of that assignment on Moodle, so you can look at it. So before we start this class, I will just use the first few minutes to explain the VBA, the Excel Visual Basic solution to that assignment. Let me go to the assignment. So this is the assignment, is problem 1.18, and is a crime scene investigation. And the question was saying that you should predict the temperature drop of the victim from 10 degrees Celsius to from the 37 degrees Celsius, which is his body temperature at the time of death. And you should predict the temperature drop using Newton's law of cooling. And let me go back to so this is the equation for Newton's law of cooling. It states that the rate of change in temperature is equal to this equation. They have minus KT minus TA, where TA is the ambient temperature or the temperature of the room, and T is the body temperature. And we are to use Euler's approximation to do that. So let me share my screen for the VBA solution. Okay, so let me So I just want to open the Excel VBA solution for that particular assignment. Okay, so this is the solution for the assignment. Is practically the same thing with what we did when we're looking at the velocity of the falling ball. So we wrote the Euler's function, and we also wrote this function. So is just exactly the same thing. The only difference, the only difference is because we have a different model. For the falling ball, the model was different. So all I did was to change this particular line in the equation. So if you look at this line very well, this is the line for the model for the Newton's law of cooling. So minus K times V. I use V to represent the temperature, that's the temperature of the body, and TA to represent the ambient temperature. So this is basically what I changed in the model. So you have two functions. The first function is for the model, while the second function is the Euler's function. It's basically the same thing with what we did. It's just that instead of using the model of the falling ball, because you have a different model, so you have to represent the model differently. And we have three parameters. For the velocity of the falling ball, we just add four parameters that we passed into the function, but we have three parameters. And the reason why we have three parameters is that this particular model for the Newton's law of cooling doesn't take much arguments. All you need is the K, the constant K, then V being the temperature, then TA being the ambient temperature. So these are the parameters you need. T is the time, because for the model is the T, that's the change in temperature as a function of time. So you just need the time, the temperature, and the ambient temperature. So you don't need four parameters like unlike the previous example. Then another thing that was changed. So remember that this is the function here. Then when you are calling it in the Euler's function, you have to call it using just three parameters, same way you did here. Then the Euler's function, previously we had 5 parameters for the Euler's function for the velocity of the falling ball. But in this case, we have 6 parameters, sorry. But now we just have 5 parameters. The 5 parameters the being that the model of the Newton's law of cooling just takes few parameters. So the first parameter is the change in time, the T. The second is the initial time, the final time. We had same in the previous model. Then this is the temperature, represented by YI. YTA is the ambient temperature, that's the temperature of the room. So we add lots of parameters in that one. We add M, which is the mass, CD, which is the coefficient, and all of those. So the reason why we're not using 6 parameters, unlike the previous case. Okay, I can see some questions in the chat. Please, can someone suggest a lasting solution to this audio problem to me? Okay, please, can you hear me? Somebody said he cannot hear what I'm saying. Please, if you can hear me, I don't know if others can hear me, or is it all of you that can't hear me? Please, if you can hear me, just indicate if you can hear me. Okay, okay. So it's only 2 people that can hear me. The others can't hear me. Okay. All right. All right. I think the person that can't hear me, I think it's probably it might be the network from your side. Then another person, please, does the YDT on top has anything to do with the Y down? And also, why is Y changed to V? Okay. The YDT, I'll just continue. So those people that cannot hear me, in case you can't hear me, just let me know. Since few people can hear me, I will just continue. And hopefully, probably with time, if you're not hearing me, probably is your network. But if you can't hear me at all, just let me know so that I would. So if all of you can't hear me, that means the problem is from my side. But if just one or two people can't hear me, that means that it's probably from your side. So the question is, this the YDT, this the YDT here is just a variable where you store the results of the model. This is the model we defined, and the model returns a value. So we are storing it here because we want to use it in the Euler's function to calculate the temperature. Then he said, why is y changed to v? The reason is that the the bone, what you want to calculate for this example is the temperature. Okay, so if you can't hear me, somebody is suggesting that you log out and try to reconnect back. Okay. Why in this example, y is not changed. I didn't change v to y. In the previous example, which is velocity, is the velocity we wanted to calculate. So that's why we add v. But now it's the temperature we want to calculate. So that's why we we have this. This represents the temperature. In the previous example, which is the velocity of the falling ball. Okay, somebody is saying I should record. Okay, yes, I'm recording. I'm recording, so you would have it. You have the video at the end of the class in case you don't understand very well. So, like I was trying to explain, in the first example, which was velocity, we wanted to calculate the velocity of the falling ball, but now we want to calculate the temperature. And then we add 6 arguments. We had 6 parameters. We had the t, which is the step size, the initial time, the final time. We had the velocity. Then we had some constants, m and cd, so which were some coefficients that has to do with the model. But this particular model, which is Newton's law of cooling, it doesn't have the parameters m. It doesn't have parameters cd, which is the coefficient. From the function, the y, okay, somebody is asking, from the function, the yt, comma v, ta is quite different from ty, ta because of the v. Yes, you're right. So the function is the yt, comma v, comma ta, where t is just the time. Then V is the temperature, while TA is the ambient temperature. So if we are done, the Y, T, V, the Y, T, Y, and TA is actually different. Okay, I understand your question. Your question is if we replace this one with Y, is it different from if we have V? Is the same thing. So if I replace this with Y, that means that I have to replace this with Y. So it's just variable. I used V, so I must use V here. If I had used Y, I can also use Y here. So it's the same thing. If I used Y, it's just a variable name. I can use any variable. I can even use, I can just make it temperature for better understanding. Then I can make this temperature. So it is just a variable name. Any variable name you use is still going to work. Just make sure that any variable that you are defining at the start of the function, you also use it within. Otherwise, that's when there's going to be a problem. And also this Y doesn't really mean anything because I used Y here. Y represents the temperature. I can replace it with temp. Then if I replace it with temp, I would also replace this one with temperature. Then I would also replace this one with temperature. Then I will also replace, instead of Y, I would also replace it with temperature. Then it's just variable name. It can be any name. It can be Y, it can be that other time I use V. So you just make sure that any variable name you choose is uniform, and so that there's not going to be a compile error. Okay. And in the declaration, yes. So you have to change it in the declaration, and also anytime you're using it. Okay, thank you. In the declaration, yes. So you have to change it as temp. So when I was declaring it, it was Y. So since I'm changing it, it has to be temp. So Patrick, thank you for that comment. So this is basically the solution for that particular question using Excel VBA. So is just the same thing with the question we did in the last class, but that one was on velocity, while this is a different model. So that particular model was actually different, but now our model is minus kt minus ta. So you need to change the model here. The other thing you need to do is to change the arguments, because here we just need three parameters. The first parameter is the time, the current time step. The second one is the temperature. Then TA is the ambient temperature. So you just need three parameters. So that's why we have three variables. In that other model, we add a lot of parameters. We add M, which is the mass. We add velocity. We add coefficients, the frictional coefficients that has to do with the air resistance. So that's why we add four parameters. Also, it's just basically the same thing. The only thing you change is the model. And if there are fewer parameters, the number of uh, parameters here will reduce. And after that, it's just the same thing. And when you are calling this function, so this function is the derivative of the temperature. You have to call it with three parameters. If you call it with four parameters, it's going to give you an error. And now we have five parameters for the Euler's function. So let me go back to the Excel VBA, to the Excel screen, and okay. So we defined another Euler's function. So if you look at it, for this first one, when we are calling it, we have to call it with five parameters, because now when we declared it, it was just five. So this is the first one, the T. Then this is the second one, the initial time, which is A10. So you have A10. The final time is A11. Then B9 is the temperature. That's the current temperature. And the current temperature is the previous one you calculated, which is B9. So you have B9 here. So this is the B9 where my cursor is. Then TA. TA is the ambient temperature. So we already defined the variable TA as 10 degrees, because in the question, TA is 10 degrees. So using the same method we used for the previous case of the velocity, so we just use it to generate the graph. So in the assignment, you actually used you used your hand to calculate it. So you can, now we're using a computer to do it. So another thing is, in order to check if your solution is actually correct, so the answers you got when you were doing it in the assignment you submitted, you can just cross check it here. So if it's the same thing, that means that you were correct when you were, your solution was correct. But if it is different, then probably you made a mistake somewhere. And similar to what I said, that the step size, the T is the step size. And I said if you have a smaller step size, you your approximation is much more correct. So if I change the step size to 0.1, okay, it's giving me an error. And the reason why it's giving me an error is because I changed it from Y to temp, and I didn't change this. Remember I told you that anytime it's just variable. So anytime you're anytime you're changing the variable, you have to you have to change it across across you have to change it across every. So the change of variable, it has to be across everything. So I will just close it and run it again because it's giving an error now because I was debugging while changing it. So let me close it and run it again so that I will get I will get okay. So I'm closing it, then I will just open it again. Okay, so I have the 8 here, then okay, so I would run it again. So when I changed, actually, before the step size was 0.5. In the question, we're asked to use a step size of 0.5. So this is the answers. So if these answers here is not the same thing with the one you got when you did it, that means that you are wrong somewhere. So I said changing the step size, it makes it much more accurate. So when you use 0.1 step size, is going to these parameters are going to change and is much more accurate. In the question, if you used 0.1 step size, these are the values that you would have gotten, and these values are much more accurate than 0.5 step size, which was the one you used. If I change it further, the values are going to change, and these values are much more accurate than 0.5. So this brief introduction is just to, because of somebody asked me about it in the forums. So that's why I took the time to explain it. So can I go on to the lecture for today? Do you understand what I did? So my advice for you is that you should, all the assignments I gave you, you should try to use Excel VBA or MATLAB to solve it, because in the assignments 2 to 4, you all did it by hand. So my advice is that you should try to use either Excel VBA or MATLAB, because we did not, I didn't give you the assignment to use Excel VBA or MATLAB to solve it. So that means that is a likely exam question, and you guys should endeavor to work it out on your own. So since I've already solved this, so this is cancelled already. So this is cancelled for the exam. So in the other questions, most especially the exams, most especially the assignments, I would encourage you, and I would advise you to try to use Excel VBA to or MATLAB, either of the two, because in the exam I will give you the freedom to choose any programming language you want, either MATLAB or Excel, VBA. So my advice to you is that the remaining assignments, which is uh, the assignment 2, assignment 4, try to use a programming language to solve it because it's a potential exam question. And please, if you have a problem, please don't don't tell me because I would not answer you. So since I've done one for you, I I I feel that you should be able to do the others. We've done 2 examples now, so I feel that you can do the rest on your own. So we are going to start the class for today. So the class for today, like I said, the class for today is on errors in mathematical approximation. So like I said before I started the class, okay, my audio is breaking. Okay, probably it's from your side. I will just start the class now. So the class for today is errors in mathematical approximations. So like I said when I started, I'm using a textbook. So let me just share the textbook again. So the textbook is on Moodle. I uploaded it on Moodle. This is the textbook we are going to be using for throughout this semester. So I applied numerical methods with MATLAB for engineers and scientists. So all my lecture notes is going to be from these textbooks, and all the assignments and everything is going to be from this textbook. So let me share the lectures just for you to know that the textbook I'm using. So when you are revising on your own, you can just fall back to that textbook and to go over it. Okay, so we're going to be doing errors today. So error is simply the difference between the true value and the approximated value. That's error. Then we'll have relative. Like I said when I started, if you have any questions, I will just go on and on and on like that. Or if you have any questions, just drop it in the chat. Then I will look at the chat from time to time and I'll try to answer it. So I will just move on. Okay, so error is the difference between the true value and the approximation. Because remember in the first class, we had a analytical solution to the model and we had the numerical solution. The analytical solution was the exact solution, but we wanted to use the numerical method. So the numerical method is just an approximation. And so being that is an approximation, definitely there will be an error. So that's why we need to measure the error. And the formula for the relative error is given by the true error divided by the true value. So this is the true error. And so that means that the true relative error is simply given by this equation. So the true value minus the approximated value, they divided by the true value. And in some cases, like we're going to be seeing, in some cases, we may not have access to the true value. So the true value is like the exact solution. In some cases, you may not even know the exact value. So, and you still need to calculate the error. So in such cases, because you don't have access to the true value, instead of using the true value, you use the current approximation, you subtract the previous approximation from the current approximation, then you divide by the current approximation. I'm going to talk more on that. We'll do examples on this so you understand what, what I'm saying better when we do when we do the example. So we have this function. This is the exponential function, exponential x. So this function, it can be approximated by this Maclaurin series. So the Maclaurin series uh, expansion of this exponential function is that this exponential function is equal to this summation. So you start at 1, then you add x, then you add this, you had the third term, you had the fourth term, fifth term, sixth term, and it goes on and on. It's actually infinite, but this n just represents when you want to stop. So if you want to stop at the 100th iteration, so this n is going to be 100. So this is the this is the exponent, this is the function exponential x, and this is the approximation for it. And we want to get the error. So we know that, so for e of x, so we know that e of x is equal to this. So we say that let x be equal to 0.5. So what we want to do now is to get the exponential of 0.5. And we know that when we do the exponential of this from your calculator, you know that this is the value you're going to get. So you know that this is the true value. But now we want to use this Maclaurin series in order to get the error. So if we use the first value, just the first value only. So if we say that the exponential of 0.5 is just 1. That's, we are simply using the first value. So this is the true value. We know that the exponential of 0.5 is this. So this is the true value. This is the approximation, and this is the true value. So our error is 39.3. If we use the first two values, 1 plus x, that's the first two values. Remember, x is 0.5. We get our approximation as 1.5. Then when we calculate the error, we're going to get this. Then if we use the first three values now, and we calculate the error, this is the percentage error we get. And if you observe the trend, so you would see that the error is actually dropping from 39%, it dropped to 9%, it dropped to 1%. Then when you use the first four values, 0.1%, if you keep on increasing the number of terms, the error keep dropping. And this example is just to show that when you have a model, you have the true value and you have the approximated value or the approximation for that particular function. You can actually calculate the error. Then the example also shows that the more the number of times you use, the error, the relative error will keep dropping, because when we use the first term only, we had a very large percentage error. Then when we started increasing the number of terms, we got much more closer to the exact value. So when we use the first six values, this is the true value, which you can simply get from your calculator. And this is the approximated approximate value using the first six terms of the Maclaurin series for the exponential function. The next thing we are going to do is that we are going to write a, a function in Excel VBA to solve this particular problem we did. And we are going to, the aim of the of the program, or the aim of the code, is to calculate the exponential of x. So we have three arguments. So let me tell you what the program is doing. The aim of the program is to calculate the exponential of x using the Maclaurin series. And what this program does is that it takes in three parameters, x being the exponential you want to calculate. For instance, if you want to calculate the exponential of 2, that means that this our x is going to be 2. If you want to calculate the exponential of 20, so x is 20, then this second argument is the error, is the estimated error. ES stands for the estimated error. Then max it stands for the maximum number of iteration. So when I was explaining the Maclaurin series for the exponential function, I said n is the last term you want to go through because it's an infinite series, like I said. So n is like your final stop where you want to stop because it's actually infinite. You can go on and on and on. So n is just when the time you decide to stop. So it takes in three arguments, x being the exponential of the function you want to do, es being the estimated error because you want to track the error, then max it is the number of iterations you want to do. So I have less than 1 minute left because I I'm using the basic version. So I will stop here, then immediately you join again. You click on the link again and you rejoin, just like what we did the last time. So I'll stop the video. I'll stop it now. I'll leave the meeting, then you rejoin again.